Hold this thought. Somewhere in Cairo, inside a glass case, there is a piece of jewelry. It is 3,000 years old. It belonged to a boy king buried with more gold than most countries have ever minted. And at its center, carved into the shape of a scarab beetle, is a pale yellow stone. That stone is not from Earth. It was not mined. It was not made by human hands. It formed 29 million years ago, when something came screaming out of the sky at speeds that make a bullet look slow, and for a few seconds, turned the Sahara Desert into a lake of fire. The glass that formed in that moment lay in the sand for millions of years, long before Egypt existed, long before anything that could be called a civilization had learned to look up at the sky and wonder where things came from. And then, somehow, a pharaoh's jeweler found it, recognized it, carved it into something sacred, and placed it over the heart of a dead king. Tonight, we are going to hold that stone in our hands and peel back every layer of what it is. And by the time we reach the deepest layer, the stone in your hand will contain a story that began before the dinosaurs disappeared. The stone was found in 1922, not in the desert, but in a tomb. When Howard Carter broke through the sealed door of Tutankhamun's burial chamber, he was looking into a room that had been closed for 3,300 years. The air inside had not moved since the reign of a boy who died before he was 20. The objects inside had not been touched. Among the thousands of treasures, there was a breastplate, a broad pectoral ornament made of gold, inlaid with turquoise and lapis and carnelian, shaped like a pair of falcon wings stretched open. And at its center, where the wings met, a scarab beetle carved from a stone Carter had never seen before. He cataloged it as chalcedony, a type of quartz. He was wrong. It would take decades of analysis before anyone understood what the stone actually was. The scarab was made of glass, natural glass, not manufactured glass, not melted sand poured into a mold. Glass that had formed by itself in the desert without any human involvement, by a process that even now is not fully understood. The glass is pale yellow, sometimes greenish, sometimes almost clear. It is the purest natural silica glass ever found on Earth. The chemical composition is strikingly simple. Silicon dioxide, almost nothing else. No contaminants. No trace elements from volcanic activity. No signs of the geological processes that normally produce glass-like minerals. It is clean in a way that natural things almost never are. And that cleanness is the first clue that something extraordinary made it. In 1932, a British geographer named Patrick Clayton was crossing the Great Sand Sea near the border of Egypt and Libya when he heard something unusual beneath his car tires. A crunching sound. Not the sound of sand. Something harder. He stopped and looked. The desert floor was covered with fragments of yellow glass. Hundreds of them. Thousands. Scattered across the sand like broken bottles. Half buried. Catching the light. Some pieces were small, the size of a thumbnail. Others were larger than a man's fist. Clayton collected samples and brought them back for analysis. The glass was real. It was silica, almost pure. It had clearly been subjected to extraordinary heat. But there was no volcano, no volcanic rock anywhere nearby, no impact crater. No evidence of any geological event that could have produced enough heat to melt desert sand at this scale. The glass covered an area of roughly 6,000 square kilometers. By some estimates, the total mass of glass in the field exceeds 1,000 metric tons. Something had melted an enormous section of the Sahara, then vanished without leaving an obvious trace. For decades, no one knew what had done it. Two hypotheses emerged. Either a meteorite had struck the surface, generating enough heat and pressure to vaporize the sand and deposit the glass. Or a comet or asteroid had exploded in the atmosphere above the desert, producing a superheated blast that melted the surface without actually touching it. The second type of event is called an airburst. Both explanations were theoretically possible. Both required energies that are almost impossible to imagine. And for most of the 20th century, the debate remained unresolved. To understand what formed the glass, you have to understand the heat. The melting point of quartz, the dominant mineral in desert sand, is roughly 1700 degrees Celsius. This is already hotter than most volcanic lava flows, hotter than a blast furnace, hotter than anything in ordinary human experience. The Libyan Desert Glass formed at temperatures significantly higher than this. Chemical analysis of the glass shows evidence of temperatures exceeding 2000 degrees Celsius. Some estimates place the peak temperature even higher. For comparison, the surface of the Sun is approximately 5,500 degrees Celsius. Whatever melted the Sahara was operating at roughly a third of solar surface temperatures, at ground level, for a period measured in seconds. The sand did not just melt, it vaporized. The silica was reduced to plasma. And then, as the energy dissipated in an instant, the liquid glass cooled. But not slowly, fast, catastrophically fast. Far too fast for crystals to form. When glass cools quickly, the atoms do not have time to arrange themselves into an ordered crystal lattice. They freeze in place, disordered, amorphous. This is what makes glass transparent. And this is why the Libyan Desert Glass looks the way it does, pale, slightly translucent, full of trapped bubbles and wisps of color where different components mixed and cooled mid-flow. The bubbles inside the glass are the most extraordinary detail. They contain gas that was trapped at the moment of formation 29 million years ago. Inside each bubble is a tiny sample of the atmosphere as it existed in the Miocene epoch, before humans, before the ice ages, before the evolution of our entire genus. The glass is a time capsule, and it is also a scar. The debate about what caused the glass was settled mostly in 2019. A geologist named Aaron Cavesey, working at Curtin University in Australia, analyzed samples of Libyan desert glass looking for something specific. He was looking for grains of a mineral called zircon that had survived the heat. Zircon is extraordinarily durable. It can survive temperatures that destroy almost everything else. And when zircon is subjected to extreme shock pressure, the kind generated by a hypervelocity impact, its crystal structure changes. It transforms into a denser mineral called rhyodite. Cavesey found zircon grains in the glass that had transformed into rhyodite and then back into zircon again as the pressure released. This transformation requires pressures that can only be generated by one thing: a solid object striking the Earth at cosmic velocities. Not an airburst, an impact. Something physical hit the ground. But there is still no crater. The crater has never been found. The leading explanation is that the impact occurred in a shallow sea or lake that existed in the Sahara 29 million years ago, before the desert was a desert. Water and sediment would have buried and eroded the crater over millions of years. Or the projectile itself may have been an unusual type, something loosely structured that transferred its energy to the surface in a distributed way, melting a vast area without leaving a clean circular scar. The honest answer is that we are still not entirely certain. The glass is real. The temperatures were real. The shock pressures were real. The impact we now believe was real. But the crater is missing. And the missing crater is one of the strangest details of a story that is already strange. Now we need to answer a different question. How did the glass get from the desert into a pharaoh's tomb? The Great Sand Sea, where the glass field lies, is not a hospitable place. It is one of the most remote and uninhabitable regions on Earth. No roads, no water, no shade. Temperatures in summer exceed 50 degrees Celsius. Crossing it on foot would be almost impossible. And yet someone more than 3,000 years ago made the journey, crossed the sand, found the glass, recognized it as something worth carrying back. We do not know who made that journey. We do not know whether they understood what the glass was. They may have found it near the edge of the field, where the dunes are less severe and the glass fragments lie exposed at the surface. They may have traded for it, receiving it from desert peoples whose routes we have not mapped. What we know is that they considered it precious, not merely decorative, precious in a sacred sense. The scarab beetle was not a casual ornament. In Egyptian cosmology, it represented the sun god Ra at the moment of rising. It embodied rebirth, transformation, the daily renewal of light from darkness. Placing a scarab over the heart of a dead king was a statement of enormous weight. The jeweler who carved Tutankhamun's scarab chose this yellow glass deliberately, from among all the stones and materials available in one of history's richest civilizations. They chose something that had come from outside, something that did not belong, something that carried within it a heat that no earthly fire could match. Perhaps they knew it was different. Perhaps they could feel it, the smoothness, the weight, the way it caught light from the inside. Perhaps they simply thought it was beautiful. Or perhaps they believed it was sacred because it had come from the sky. They were right in ways they could not have fully imagined. Let us hold the scarab in our hands and count what it contains. On the surface, a carved yellow stone, pale, waxy, cool to the touch, the shape of a beetle whose wings have been stylized into geometry by a craftsman working by lamplight 3,000 years ago. Beneath the surface, glass, not manufactured glass but natural glass, formed in an instant of catastrophic heat. Inside the glass, bubbles of ancient air, trapped in the moment of cooling, containing molecules that have not been touched since long before our species existed. Inside the glass, scattered grains of zircon and rhyodite, recording the shock pressure of a cosmic impact in their crystal structure. A mineral memory of a collision that no living thing witnessed. Beneath the glass, the sand that was melted to form it. Desert sand, composed of quartz grains eroded from ancient mountains that have long since disappeared, carried by winds that blew across a landscape that no longer exists. Below the sand, a shallow sea or lake, now gone, that may have swallowed the crater. A body of water in a desert, an ocean in a place that has been dry for millions of years. And at the very bottom of the stack, the origin of the impactor itself. A rock or a comet or a loosely assembled pile of ice and dust that fell from somewhere in the outer solar system, or from a debris field between Mars and Jupiter, or from further still. An object that formed when the solar system was young and drifted for billions of years before its final appointment with the Sahara. What you are holding, if you could hold it, is not a stone. It is a compressed record of 29 million years, a pharaoh's understanding of the divine, a geological catastrophe, and a journey from the outer solar system to the chest of a dead boy king. All of it in something small enough to fit in your palm. The meteorite I described in a previous video formed over millions of years of slow cooling. The Widmanstatten pattern grew at a rate of atoms per century, patient beyond anything human civilization can imagine. This glass is different, formed in seconds. The same deep time, the same vast scales, the same ancient origin. But the glass itself was made in a flash. A moment of total violence, heat beyond imagining, and then silence. The desert reformed around the new material. The dunes moved, the seas dried, the continents shifted slightly. The ice ages came and went. Creatures evolved, flourished, disappeared, and the glass waited. It did not change. Glass is not a crystal. It has no ordered structure to break down, no crystal planes to slip, no grain boundaries to corrode. It is frozen liquid, and frozen liquid is remarkably stable on geological timescales. The glass that lay in the sand 29 million years ago is chemically identical to the glass that Carter found in the tomb. Nothing happened to it. Time passed around it, through it, over it, and it remained exactly what it had been on the day it formed. There is something almost incomprehensible about that. The Earth changed completely in 29 million years. Everything alive changed. Everything geological changed. The Sahara itself changed, from sea to forest to desert and back, in cycles we can barely trace. Human civilization, from the first stone tools to the present, fits inside a single % of the time the glass has been sitting there. And the glass, through all of it, stayed the same. The stone that shouldn't exist is sitting in a museum in Cairo. It shouldn't exist because the conditions that made it are almost impossible. The heat required, the speed required, the precise geometry of impact, the survival of the glass through tens of millions of years of geological change, the journey across a hostile desert by people who had no understanding of what they had found, the decision of a craftsman to carve it into the shape of a sacred insect and place it over the heart of a king. Any one of these steps could have broken the chain. The glass could have been buried beyond recovery. The desert travelers could have walked a different route. The craftsman could have chosen a different stone. Instead, here it is, a pale yellow fragment of catastrophe, worn over the chest of a boy who ruled the world's greatest civilization 3,000 years ago, now sitting behind glass in a museum, while outside the city goes about its business, unaware that a few hundred meters away, there is an object older than the human species, still holding within it a bubble of air from a world that no longer exists. You do not need a telescope to look at ancient history. Sometimes you just need to look at the right stone. Good night.